My name is Brianna Ragland, and today I will be presenting a midterm exam for Intro to Networking. Today, I will be setting up an IT infrastructure for the Health First Clinic, which is Group 3. I will be given the IP address range 192.168.1.0/24. I'll be needing to create 6 different subnets for the following departments: receptionists with 10 devices, medical staff with 20 devices, billing department with 5 devices, laboratory with 15 devices, administrative staff with 8 devices, and telehealth services with 5 devices. Let's go ahead and jump right in with why do we subnet? Subnetting is very important in networking because it allows organizations to divide large networks into smaller, flexible subnetworks, which makes it easier to move around in the network with more security. Better security, less traffic. Less traffic, better security. Think of it like this. When you get on the interstate and it's just yourself, you know you're secure. That's a good way to think of subnetting and remember those two very important details. Now we're going to get into subnet mask. A subnet mask is in charge of dividing the IP address into two different 32, well, not different, two different portions that sum up to 32-bit numbers: the network and the host. The two variables control whether a host is on the local subnet or a remote network, so the correct packet can be sent out by the router. These two variables are very important for communication and routing between devices. Class A, you'll see here, the network has there's 8 network bits, which means there's 24 host bits, giving a total of 32 bits. Class B contains 16 network bits and 16 host bits. Class C, which is what we'll be working with today, contains 24 network bits and 8 host bits. With that being said, I'm going to go ahead and give you the solution. I seem to have got some of my note cards mixed up. With that being said, I'm going to start off by giving you my solution to this assignment and breaking down the math and reasoning behind it. This is the address that we start with, and we will be borrowing from the host. So we take 3 from 24, which gives us 27. The host is 254 with the subnet right here that we'll get into in a few slides, which then refers to 30 per subnet throughout 8 subnets, which I left 2. I'm only supposed to use 6, but I left 2 for growth. Starting off, we have 192.168.1.0 as the IP. And before we can calculate the subnet mask, we need to turn this number into the binary numbers. So the way we're going to do that is we're going to take each octet, which is the 8-bit, 4 different octets of this. It will be determined if it is less than or equal to each number starting down here from left to right from this chart. We'll go in order, and I'll do it for example. 192, we'll say, does it go into 128? Which it does. So right here, we're going to put a 1. And then we're going to subtract 128 from 192, which gives us 64. And does 64, well, we'll do that. We'll give us a 1. Does 64 go into 64, excuse me? And it does, so we'll put a 1 here. And then we'll subtract 64 from 64, and that'll be 0. So none of these other ones can go into that, so we're going to have to place all the other 6 as 0. And that'll be it for the first octet. Then we'll go over to 168, and we'll say, does that go into 128? And it does, so we put 1 here. Then we subtract 128 from 168, and we get 40. And 64 doesn't go into 40, so we put 0 here. But then 32 does go into 40, so we put 1s here. And then we subtract 32 from 40, which leaves us with 8. And 16 doesn't go into 8. So again, we put a 0 here. But 8 goes into 8. So we put a 1 here. And then we subtract 8 from 8. which gives us 0. So we know all those other numbers are 0. Now we know 1 doesn't go into any of these numbers until it gets to 1. So we put 0 all the way until the 8th place, and we put a 1. And then we put 8 zeros for the last octet because it's 0. Now, same thing here. This is just, I wanted a diagram to show you we go from 24 and we'll go from 27, and right here we'll show you how we do that. We'll convert this subnet mask, which it makes it easier because we know that for each 255, our binary, our bit is 1. So for this one, for the first octet, we'll have 8 ones. For the second octet, we'll have 8 ones. For the third octet, we'll have 8 ones. And then for the last one, we'll have 0. We'll take 2 to the power of however many zeros we have, which is the host, and that's 8 minus 2. So it'll be 2 to the power of 8 minus 2, which equals 254. And that is the binary number that we start out with that one. But then we're going to borrow 3. So remember, we borrow 3, and it'll change our whole equation. So these 3 zeros right here now turn into 1s, and it'll become 2 to the power of 5 minus 2, which is how we get 30 hosts. This is a summarization of that setup, no crossing between anything. And yeah, this is a breakdown of the equivalence of what we need to make sure that we have all of our hosts available, and we left plenty of room, future growth. We left 60 hosts for future growth because we don't know how much we can expand. Thank you.